Good morning, everyone. Welcome to your heat transfer experiment number 2. Heat transfer from extended surface, we also call the film performance. In order to do this experiment, you need 2 devices. Number 1, that's the surface unit. We have used this before. Number 2, that's going to be the extended heat transfer module. And this extended heat transfer module actually is a brass bar coated with insulating material with total 8 thermocouples embedded to measure the temperature distribution. And also on the base side, this is the base side, with an electrical heater. And we also have like one more thermocouple actually measures, that's thermocouple 9, measures the room temperature. Once those heat transfer from extended surface module connected to the surface unit, we will be able to measure the temperature distribution. Okay. Now first, let's set up the equipment, connect this to the power cord. This is the power cord for the surface unit. This is the power source for the electrical heater connected to the back side of the surface unit. We also need to connect all total 9 thermocouples to the surface unit. Please check the label of the thermocouple. This is a thermocouple with a label number 1 connected to T1. This is thermocouple number 2. You need to connect this one to T2. And do the same thing for all the other thermocouples. So now the thermocouple and also the module and the surface unit all being connected. You can start to do the experiment. Let's start the experiment for the first part. The surface unit actually already turned on. For the first set of data, we need to set up the voltage to be about 9 volts. Again, this is going to be the voltage setup for group number 1. Please refer to the manual to find out the voltage input for your group. So now I'm trying to set up the voltage to be 9 volts. So this is the voltage input, 9 volts for group number 1. And also you will be able to get the current reading, which right now equal to 0.31 amp. Now if you use the voltage multiplied by current, you're going to get a constant. Now that constant is going to be the constant input for the electrical heater. And that's also the constant heat transfer rate from the base through the extended surface to the environment. Okay. Then when the temperature becomes steady state, you will be able to collect the temperature value. How do you know the temperature right now becomes stable? You need to monitor the temperature value of any thermocouple. Let's say right now we are looking at the temperature value of thermocouple number 1. If you notice that this value, temperature value, does not change for about 90 seconds, then you can start to record your temperature value of T1 all the way to T9 and also the voltage and the current. That's going to be your first set of data. Okay? And then we can change the voltage setup to be 14 volts. Again, that's going to be the voltage input for group number 1. Please refer to the manual to find out the input voltage for your group. So now I'm trying to set up the voltage to be 14 volts. So this is the voltage of 14 volts. Again, you can also, just like before, get the current reading by turning the knob to the I. And the voltage multiplied by current, again, that's going to equal to the constant input to the electrical heater. That's also the constant heat transfer rate from the base through the extended surface to the environment. You have to wait another 20 to 25 minutes to let the temperature become stable and collect your second set of data, which include the total 9 temperature values and also the current and voltage. This will complete your heat transfer experiment number 2.